In practice, it can be observed that like terms show pertinent characteristics when they feature in number operations in algebra. What exactly are some of these characteristics of like terms when they feature in selected number operations in algebra? That takes us to the sixth lesson objective of this lesson, and that is arithmetic of like terms. In this section, we learn the way like terms behave when we carry out addition, subtraction, multiplication, and division with them. Do they cooperate all the times? In this section, we see answers to all of these questions. Please follow through as I delve into this section. Again, it is arithmetic of like terms. Now let us take objective number 6, arithmetic of like terms. If you watch the screen, you will see two sets of numbers. This set and this set. 6 bracket 3 means 6 threes. 2 bracket 3 means 2 threes. 6 bracket 3 and 2 bracket 3 are like terms. I hope you know why. Let me remind you. 6 is counting how many threes, and 2 is also counting how many threes. Because the two count the same thing, they are called like terms. Because 6 is counting how many threes, and 2 is also counting how many threes, the two number expressions are said to be like terms. Permit me to replace this 3 with y, so that in this case we have a corresponding expression 6y, and from here we have a corresponding expression 2y. That is, if 3 is replaced by y and 6 remains, let it become 6y, and 3 also replaced here by y and 2 remains to make 2y. In this section, we want to learn how to carry out addition, subtraction, multiplication, and division of like terms. By means of numerical experiments I wish to carry out, I want to give formulas as to whether it is possible to add, subtract, multiply, or divide using like terms. After such numerical experiments and results that come from them, we will now have a better chance to make laws regarding the arithmetic of like terms, that is, addition, subtraction, multiplication, and division of like terms. Now, let me start with addition of like terms. Please watch out. Now look at the first addition of these two number operations, which we regard as like terms. I want to add 6 bracket 3 to 2 bracket 3. See it happen here. 6 bracket 3 plus 2 bracket 3 by default means add what you get here to what you get here. 6 bracket 3 means 6 threes, and 6 threes is 18. 2 bracket 3 means 2 threes, and 2 threes is 6. I hope you know why. Okay, at this point, since 18 comes out from here and 6 comes out from here, the number operation between them is addition, so 18 plus 6 is equal to 24. Now, permit me to add these two differently. If I add this 6 bracket 3 to 2 bracket 3 in a different way, and I still get 24 as the answer, that one, if found consistent, will be found as alternative method of adding the 2. Please follow me as I use a different method to get the same 24, apart from what I just did here. And here comes that alternative method of getting 24 from addition of 6 bracket 3 and 2 bracket 3. See it here. 6 bracket 3 plus 2 bracket 3 means 6 3s plus 2 3s. If I add 6 3s to 2 3s, I will be getting 8 3s. I hope you know why. If you put 6 3s to 2 3s, logically, and by any other means, we know that the result is going to be 8 3s. And 8 3s is equal to 24. Therefore, the new thing is that we now have 8 3s. And in this first line of action, we got 18 plus 6. But here, in this second line of action, in this second stage that corresponds to second line of action, we got 8 bracket 3. So notice that what I got in this second stage is not the same thing as what I got in this second stage. The two are different, and yet the answer is the same thing. 24, 24. 8 bracket 3 is an answer to this number operation, and 24 is also an answer to the same number operation. What it means is that we can conclude that 6 bracket 3 plus 2 bracket 3 is equal to 8 bracket 3. We can also conclude that 6 bracket 3 plus 2 bracket 3 is equal to 24. So either this or this is an answer to this one. But I want to ask, if this 3 is replaced by a variable, that is letter of alphabet, which stage of the answers between these two and these two will still be possible, and which one will now be impossible? Okay, permit me to bring in this 6y and 2y, so that this 6 stands where it is, and then 3 will now be replaced by y, 2 stands where it is, and 3 replaced with y. Let's see which one is possible of the two steps. Before then, let me write the result separately, that this number operation is equal to this. The same number operation is equal to this. Please watch out. And now see them. Do you agree that these results are correct? Yes, from here, this is equal to this. See it here. This is also equal to this. See it here. In pure arithmetic, where only constants are used in carrying out number operations, both this result and this result are possible. That is, as long as every number used in this operation is a constant and not a variable, both this result and this result are possible. But when we do arithmetic of algebra, only one of these two is possible. Please, like I said earlier, let me replace this 3 by y and this 3 by y. Let us now check whether it is 24 we're going to get as the answer, or 8 bracket something we're going to get as the answer. I said earlier, just a short while ago, that in pure arithmetic, both this and this are possible as the answers to this same number operation. But in algebra, only one of them will become possible. Let's find out. Now see what I mean. 6, then y. As long as y is here, it now means that anything can be here, not just 3. We simply mean, imagine that we don't know what 6 is counting. 6 could be counting 3s. 6 could be counting 2s. 6 could be counting 5s. 6 can be counting just anything. That just anything is y. The same thing applicable here. 2 3s, that is 2y. Remember what you want to achieve here. We want to find out which of these two results is possible in algebra. I said before that both of them are possible in pure arithmetic. Now we are dealing with algebraic expressions. Which of these two is possible? Or are they still possible as two answers to these number operations? Again, look at this number operation, 6y plus 2y. Do you think we still get a constant, 24, as the answer? That is impossible. But is it possible to get it in this form? Surely. Remember that 8 is here and 3 is here. But this 3 is no longer the 3. It is replaced by y. Therefore, is it in this form or in this form that we're going to get the answer of this number operation? Obviously, we can't get it in this form, but in this form. What then is the answer to 6y plus 2y? Judging from what happened in these two lines of action, please watch out. The answer is now equal to 8y, and that is what it is. Which means it is this first one that becomes possible if we add the two number operations when they take the form of algebraic forms. So here we have the same 8 here, but y has now become 3 has become y. Consequently, 6y plus 2y is equal to 8y. If 3 is what is here, the answer will now become 24. If 2 is what is here, the answer will now become what? 16. If 5 is what is here, to replace this y, the answer now becomes 14. So, at this point in time, we are coming close to deriving a formula for adding like terms. Before then, notice that this 8y took the structure of this 8 bracket 3. But in this we have 8, then bracket 3. But this we have 8, no bracket. We just wrote y. Why is it so? This one is obvious that 8 and y are not two digits of the same number. Instead, they are different numbers. But if I wipe off this bracket here, we will now call it 83, no longer 8 bracket 3 or 8 3s. So when a constant counts a constant as a coefficient, it is important to separate them with a bracket or sign of multiplication. But when a constant counts a variable, it is not necessary to provide a bracket, as you see in this form. So it is this that we have come to write in this form. Again, don't insist on using brackets to separate constants and variables when the constant is serving as a coefficient of that variable. Now, let us try to summarize by looking at this last result with view to developing or extracting a formula or a law for adding like terms. 6y and 2y are like terms. When added, the result is 8y. To get the formula, we ask ourselves, how was this 8 obtained? It was obtained by adding 6 to 2, and then y came to stand as a common factor. In other words, we add like terms by factorization. The law that follows, that summarizes what took place here, will help us conclude that we add like terms by means of factorization. Permit me to use a space here to write the law of addition of like terms. Please see. And here comes the summary, which in turn is called the law of addition of like terms. Let this 6, which is a constant, be A. Let this 2, which is also a constant, be B. But as you can notice, both of them contain y. Y is here, y is here. Likewise, y is here, y is here. So let 6y be ay, and let 2y be by. So we learned earlier that this 8 was gotten by adding 6 to 2. Therefore, that 8 is gotten. Let that 8 be A plus B. That is 6 plus 2, corresponding to this A plus B. I hope you now know why this A plus B is here. Thank you. So 6 plus 2 is this 8. Likewise, A plus B. We cannot give any answer to A plus B because we don't know whether the constant will remain 6 all the time and 2 all the time for B. That is, we don't know whether at all times this constant A will be 6 and this constant B will be 2. If we are sure that A will always remain 6 and B will always remain 2, then we should write 8 here. But A plus B is written because the constants can change. Somebody can come here and write 9y plus 11y. That way, the answer will not be 8 here. Instead, we're going to have a new set of numbers, A and B. When added, will become the coefficient of y. So this is a law of addition of like terms. I hope what happened here is clear to you. Let us now turn to subtraction of like terms. And here it comes. What is now going on is a subtraction between 6 bracket 3 and 2 bracket 3. We now have 6 bracket 3 minus 2 bracket 3. Let us first get the answer using a default method. By default, we simply mean let 6 bracket 3 turn to one number and let 2 bracket 3 turn to one number. Subtract this one number from this one number formed as a result. Alright, 6 bracket 3 turns to 18. 2 bracket 3 turns to 6. And what we have here is minus. So 18 minus 6 is equal to 12. It therefore means that by default method, this minus this will give us 12. Now, let us look at a different method of getting the same 12. See it here. 6 bracket 3 minus 2 bracket 3 means 6 3s minus 2 3s. Somebody has counted 3s into 2, and then he wants to remove 2 3s out of what he has counted. What will that remain? It will remain 4 3s. That is how we got this answer, 4 bracket 3. That is 6 bracket 3 minus 2 bracket 3 is equal to 4 bracket 3. Please confirm that you know and agree that this minus this will give us this. Then 4 bracket 3 will still give us 12. Why? 4 bracket 3 means 4 times 3. And 4 times 3 is the same 12 we got earlier. With this method, the answer is 12. With this method, the answer is also 12. In like manner, let me summarize the results. That is, this is equal to this, and this is also equal to this. Please see them. And here they come. 6 bracket 3 minus 2 bracket 3 is equal to 4 bracket 3. That is, this statement is a part of this long statement. I simply have to extract that this minus this is equal to this. See it. And then this second line is telling us that this number operation is also equal to 12. See it here. 6 bracket 3 minus 2 bracket 3 is equal to 12. Like before, let me inform you that if we carry out such number operations in pure arithmetic, where every number is a constant, both this answer and this answer are possible. But when we turn to pure algebraic expressions, only one out of these two results is possible. Since only one is possible, it has become imperative for us to derive a formula for subtracting like terms. Don't forget that 6 bracket 3 and 2 bracket 3 are like terms because 6 and 2 are counting the same thing, that is 3. Now, permit me to replace this 3 by y again and this 3 by y again, and let 6 and 2 remain the way they are. Please watch out. And here it comes. This 3 is now y, this 3 is now y. As long as y is written here, it does no longer represent only 3. It represents any other constant at all. So 6 3s has become 6y. 2 3s has become 2y's. And so, since 6 bracket 3 minus 2 bracket 3, which correspond to 6y minus 2y, give us 4 bracket 3. Since this is now what we're doing, we are doing a kind of subtraction involving algebraic expressions. Is 12 still possible to come as the answer? The answer is no. Because we don't know what y is and we don't know what this y is, we cannot for sure say that the answer to this is 12. It is 12 if only you are told that y remains 3. But because y is a variable, it could be 3, it could be something else, then we can no longer be sure that the answer is equal to 12. But we can be sure that the answer is 4 times whatever that y is. Therefore, 4 times whatever y is going to be remains the result. So this is possible. This structure of the answer is possible in pure algebra, but this constant is not possible in this algebra. Based on that, 6y minus 2y is equal to 4y. What really happened that made us get this 4 as a coefficient of this y in this last answer? Obviously, this 4 must have come from saying 6 minus 2. Based on that, I want to write the result that will serve as a law for subtracting algebraic terms, which are like terms. I will not write a separate result. Instead, I want to modify this standing result. This law is a law for addition of like terms, but a similar result has come to be after testing with subtraction. Based on that, all I will do is to effect a change. I'll simply come here and write plus or minus, meaning that whether we are adding like terms or subtracting like terms, this structure is the law on how to do such. Please follow me as I append minus under here and minus under here to reflect plus or minus in each case. And that is it. AY plus or minus BY is equal to A plus or minus B, then Y. Meaning, if you are adding, let plus alone serve. If you are subtracting, let minus alone serve. But it appears that the same law accounts for both subtraction and addition of like terms.